Now, dear student of class 12, today I am also going to continue with the derivative. Now, sir, today we'll discuss some typical questions. Now, differentiate each of the following functions. Now, the first question is y is equals to sine inverse x over 1 plus x. Now, for this question, we cannot substitute x equals to some trigonometry. So, how to differentiate this kind of functions? First, you have to differentiate sine inverse. The whole thing is considered as x. Then, we'll apply u upon v. Now, sir, differentiating with respect to x, it will be dy by dx. Now the derivative of sine inverse, this whole thing is x, consider as x. Derivative sine inverse x is 1 by on the root 1 minus x square, means x over 1 plus x whole square into dy dx of x over 1 plus x. Now we can separate the power functions over here. X square over 1 plus x whole square into dy dx of u over v square, then v dy dx of u minus u dy dx of v1 plus x. Now then I'll take LCM within a root. Then if I take 1 plus x square LCM, then this will be 1 plus x whole square minus x square over 1 plus x whole square into 1 plus x dy dx of x is 1 minus x dy dx of 1 is 0 plus 1 over 1 plus x whole square. Now after this I'll simplify over here these things. Now this quantity is on the root. This is whole thing is within a root. Root and square get cancelled. Now then we can write this is equals to 1 over this one. I'll use formula a square plus b square plus 2ab minus x square. Root and square get cancelled. Now it is 1 plus x. Okay, fine. Now then over here this is equals to, if you simplify this one, 1 plus x minus x divided by 1 plus x whole square. Now this and this get cancelled, x get cancelled, x square get cancelled. Now the final answer will be 1 over, first I'll write this, 1 plus x on the root 1 plus 2x. This is the required answer. Now before doing this numerical, I'll explain some properties of logarithms, some of the properties that you have to remember. The first property of logarithm, suppose if it is log m to the power n base e, n log m to the base e. If nothing is given, always that you have to consider the base is always e. First property. Second property, log m into n is log m plus log n. Third one, log m over n is log m minus log n. Fourth property, log m to the base n. Now actually this one is the change of base property. This is very important. Change of base property. Frequently we'll use these things in integral or in derivative. So now say log m to the base n. Now any of the bases are given over here n, but you have to make it e. Then we can write first property, log m to the base e divided by log n to the base e. Or the same property we can apply this way also. Log m to the base e into log e to the base n. The given quantity that you can write in diagonal relations. In derivative, this much of logarithm will use. No sir. Now this look like a complicated functions. First I'll simplify these things. Now sir, y is equals to log. Root means actually this is to the power half. Now then I'll apply this property, log m to the power n. Let us suppose this whole thing is m to the power n. N is half. So we can write half log 1 minus sin x over 1 plus sin x. Now next we'll apply this property, log m over n from third property. It is in terms of log m over n. Now then we can write half within bracket log m minus log n. Now after simplification, now you can differentiate these functions. It would be better for logarithmic property you take a screenshot of all these things, okay, and copy all these things in your copy. Now I'll drop this one and then I'll differentiate. Now I'll apply the derivative over here, differentiating with respect to x. Log 1 minus sin x. First we'll differentiate log 1 minus sin x into derivative 1 is 0 minus derivative sin x is cos x minus this one log 1 plus sin x. Same way I'll differentiate 1 plus sin x into derivative 1 is 0 plus derivative sin x is cos x. Now after simplification, what we'll get over here, I'll write these things here. Now this one will be dy by dx is equals to half, within bracket it will be, after simplification it will be 1 minus cos x over 1 minus sin x minus cos x over 1 plus sin x. Now then I'll take LCM, 1 minus sin x into 1 plus sin x LCM. If I take these two quantities LCM, then you know about the LCM, plus sin x minus cos x into 1 minus sin x. Now then half, I'll multiply, I'll open this bracket, cos x minus sin x cos x minus cos x minus into minus plus sin x cos x. Now the denominator is in terms of formula a plus b, a minus b means we can write a square minus b square. Cancel, half minus cos x is minus 2 cos x, and I'm going to use one more formula, 1 minus sin square theta is cos square theta. Same way 1 minus sin square x is cos square x. So that these two get cancelled, 1 cos get cancelled. What we have over here, minus 1 over cos x. 1 by cos is sec x. Now the dy dx of this function is minus sec x. Now in this question also, now the question is in a different form. Y is equals to log of cos x to the base sin x. Now over here the base is sin x, but we cannot differentiate any of the base. Clear? We have to convert the base in terms of e. So I'll use this property. Now it is in terms of, question is given in this form, log m to the base n. So I'll use this property, log m to the base e divided by log n to the base e. Now compare this property and this numerical. What you'll get, in place of m you will get cos x, in place of n you will get sin x. Log cos x to the base sin x. So I'll write this thing is equals to, y is equals to log cos x to the base e divided by log sin x to the base e. Or it's not mandatory that you have to write base e. Without base you can write this way. Now then apply u upon v formula, differentiating with respect to x. V square, then v dy dx of log cos x minus log cos x dy dx of log sin x. After this derivative formula, log sin x into derivative log cos x will be 1 over cos x into the derivative cos x is minus sin x minus log of cos x, derivative log sin x is 1 by sin x into derivative sin x is cos x divided by log of sin x whole square. Now then, sin upon cos is tan minus tan x into log of sin x minus cos upon sin is cot x into log of cos x, and denominator will remain same, log of sin x whole square. And you leave your answer like this, or you can take minus common from this. Okay, now say in this question I'll use substitution. You cannot differentiate directly this question. Now I've already given you a substitution. 1 minus x or 1 plus x means always that you have to consider let x is equals to cos theta or cos 2 theta. I'll use cos theta. X equals to cos theta. Y is equals to sine of 2 tan inverse of under root 1 minus cos theta over 1 plus cos theta. Y is equals to sine of 2 tan inverse 1 minus cos theta. It's a formula 2 sine square theta by 2. 1 plus cos theta is 2 cos square theta by 2. Cancel. So sine square over cos square is under root tan square theta by 2. Root and square get cancelled. Now we have over here y is equals to sine of 2 tan inverse of tan theta by 2. Now the tan inverse of tan theta by 2 is using property of inverse trigonometry. It will be tan inverse of tan theta by 2 is theta by 2. So that 2 to get cancelled. Now we have over here y is equals to sine theta. Now the sine theta that I'll convert in terms of cos. Sine theta means under root 1 minus cos square theta. Why I'm converting this in terms of cos? Because the value of cos is x. Then cos theta is equals to x. In place of cos square theta we can write 1 minus x square. After simplification, differentiate. Differentiating with respect to x. Derivative root 1 over 2 under root 1 minus x square into the inner function derivative 1 0. Derivative x square 2x minus 2x over 2 under root 1 minus x square. This and this get cancelled now. It is x over under root 1 minus x square. This much we'll do today. Now the first order derivative, the video is over. Now from next video that you'll get from second order derivative. Still the derivative, one more chapter is there. Next video will be of second order derivative. Thank you.